Hello, my name is Ruben and I'm a deployment strategist here at Pallantir. In the last couple of months, I've spent a big chunk of my time to deploy process mining and automation solutions using our products Foundry and AIP across our customer base. And today I want to show you an example for such a solution, so that you can go out there and apply the same set of tools to your organization's business challenges. This video comes as part of our Building with AIP series, in which we show different kinds of solution patterns for deploying AIP on your enterprise. The goal of this series is actually twofold. At first, we want to show you the art of the possible. What kinds of solutions can be built using this specific platform? And secondly, it's about showing you how you can go into the platform and build this yourself. Let's start by quickly taking a look at the process mining and automation solution that we'll build together by the end of this video. In this application here, we're looking at a process model of an order-to-cash process that represents the business reality of our notional company, Titan Industries. And the process that is illustrated here basically covers all the steps from a sales order item being created, to goods being delivered, to invoices eventually being paid. Probably every single business on the planet operates this process in some form. In the context of this process flow, we've been alerted by a senior finance manager that there seems to be a problem with the resolution of credit blocks in this process, that we should investigate it and come up with resolution proposals. So if you're not an order-to-cash expert, you might now ask yourself, what is actually a credit block? A credit block is basically a risk management mechanism in most ERP systems used for customer order management. The idea here is to block orders from being fulfilled when there's a high risk of the order not being paid for by the customer. Using this process flow graph, we can actually see how this occurs in the process. When we pull over the slider here to unveil more variants of this process, you can actually see that in 2% of cases, sales orders are directly blocked after they're created. And this is of course a big problem, especially when orders are blocked even though they will most likely be paid, right? If a customer has always paid on time historically, now gets a delayed fulfillment of her order, she will definitely not be happy, as it of course takes time to remove such blocks. In many companies, some person has to manually go into the system to remove such blocks. And this is exactly what is the case here. We know that because we have mined the process data from the source system in which these credit blocks are activated and removed. So we can quantify how long it takes to resolve these blocks. And with 9 days, which we can see on the top right here, the situation is really, really bad, at least on average. We want to be able to act more quickly than those 9 days. And we can use AI to do that. In the Take Action tab of this application, we can see in detail how this works. In this tab, we see all currently credit blocked sales orders. When we click on Show AI-generated resolution proposal, we move into an operational view for making a decision on whether to unblock this given order or whether to keep this credit block active. At the top of this view, we can see all relevant information for making the decision on what to do here. And at the bottom, we can see an AIP Copilot view. So here we basically have an AI reason to us on how this decision should be made. Right? We see a proposal on what to do here. We see the reasoning behind it, and we also see an animation of how taking the proposed next step would affect the ongoing process flow for this given sales order item. The underlying idea here is, of course, that by having access to such a copilot, or by even going beyond it with full AI-driven automation, we can significantly decrease the time needed to deal with these credit blocks. Because by this, we don't need full 9 days to make this decision. Either a human can directly accept what the AI comes up with, or the AI automatically executes what is proposed here, and this can be done obviously within seconds. And of course, this is just one example of how we can apply this principle for orchestrating process decisions using AI. You can apply this paradigm to basically any process challenge that requires someone to make a decision on something in a process. So while we build this out in the following, I want you to keep thinking about how you could apply this to your specific process challenges in your organization. Throughout the course of this video, we will build the application that we just went through from the ground up. So before we start building, let me quickly run you through the individual product capabilities that we will use for this. We will start by syncing the data from Titan Industries to our platform using HyperAuto, which is our out-of-the-box data integration tool. We will then use Pipeline Builder, our low-code, no-code tool for building production-grade pipelines to bring the synced data into the correct schema needed for process mining. After that, we'll develop the order-to-cash process mining ontology and connect it to the overarching ontology of Titan Industries. You can think of this ontology as the decision-centric model of the enterprise, which brings together data, logic, and action. Once the ontology is then ready to go, we will wield it to mine the order-to-cash process using Machinery, our application for process mining and modeling. We'll then embed this mine process into an end-user-facing application using Workshop, which is our low-code, no-code tool for building applications. The only thing that'll be missing at that point is making this whole workflow and the ontology around it AI-centric. We will therefore use AIP Logic to do that, which is our no-code, low-code development environment for building LLM-backed functions. Finally, we'll deploy our automation suite Automate to execute this AI-centric decision-making tool at scale. To begin with, we need to bring in the relevant process data from all source systems that are used to operate the process. For Titan Industries, the order-to-cash process is operated in SAP, for which we've already established a connection, as we can see here. So we can just deploy a HyperAuto pipeline out of the box. Doing this is as simple as clicking Create Pipeline. In the appearing wizard, we just have to follow the instructions now. So in the beginning, we define a name and location. SAP S/4HANA HyperAuto order-to-cash looks good. Location is also in the right folder, so let's continue. Then we define the source configuration. We'll just set up a direct batch connection for now, but there are also other options, as you can see here. In the next configuration menu, we have to select the relevant tables. We can either search for tables manually by the human-readable name. We can also use an AI assistant to suggest the relevant tables for what we want to do. However, for this specific case, there's even a workflow bundle of tables for order to cache. So we can just click on Select All, and they're all directly selected, and we can just proceed from here. Lastly, we can set up a pipeline configuration. And this is really powerful because there are a lot of features here that allow data engineers to save a lot of their time, right? Something like automatic joins, generating primary and foreign keys, or translating column and table names into their human-readable form. All super useful, so we'll just leave all of these settings on and click on Create HyperAuto Pipeline. We can now see that the pipeline is starting to be deployed. So let's skip forward from here until everything is ready. So we can now see that all of the tables are ready to work with. When we go into the output datasets, we see that these pipelines have been built and the datasets are now ready to continue working with. So now that the data is synced, cleaned, and made human interpretable, we can move onward to the next step. And that is bringing all of this order-to-cash process data of Titan Industries into the correct format for process mining. In order to do that, we need to create two datasets. The first of these is the process object dataset. And this basically describes the type of object that moves through the process. In a car manufacturing process, for example, this would be the vehicle. Whereas in a recruiting process, this would be the candidate that's going through the different stages in the process. And in this particular case here, where we're looking at an order-to-cash process, of course, this process object is the sales order item. So let's have a quick look at what this looks like. There are a couple of attributes that describe really well what this means. So in the beginning, and this is kind of mandatory, we need a primary key for this process object dataset, right? Something that uniquely defines every single process object. So this is kind of the system key from the SAP system that describes a particular sales order item. Then there are also additional attributes like the date of creation, the material number, the customer that's involved, or the net value of the sales order, as well as the credit status. The second type of dataset that we need to build is the log object dataset. And this dataset basically describes the steps that a certain process object moves through. So this is kind of a one-to-n relationship to the first dataset. And when I look at the preview here, I can basically only see 3 columns that are needed. And this is universally true for basically all kinds of log datasets. The first column is the primary key of the process object. So this is a reference to the sales order item in this case. That's really important because, of course, this has to be linked. The second column is just the state that we're currently in, right? So in this case here, this logs the sales order item being created, that's one state in the process or one step for this specific process object. And then there's the timestamp at which this state was kind of entered. So how do we get there? How can we bring the synced SAP data into the correct schemas that we just talked about? In order to do that, we can use Pipeline Builder, which is our low-code, no-code tool for developing production-grade data pipelines. I click on Create New here, I get brought into this new interface here. I can specify a pipeline name and a location and can then kind of select the pipeline type. So let's click on Create Pipeline to continue with the next step. What we can really easily do from here on is just to add any kind of data set that we want to transform and bring to a different format. So in this case, of course, all of the ingested SAP data about the order-to-cash process. So we can just click Add All to Selection, and then add the data. And here we have all of these tables ready to be used in Pipeline Builder to be transformed. And there's actually a lot of different kinds of things that you can do here. We just select one table and then we can see what kind of different options we have, right? We can apply transformations here. We can use a library of hundreds of functions to do any kind of transformation that you would want to do for transforming data. Super powerful. Probably can only scratch the surface of what we can do here for process mining, but also very useful in different other domains. We can join tables with one another. We can union results. We can generate transforms using AI. So a lot of different things. We can also adjust pipeline profiles. So this really is a super powerful feature to build scalable pipelines, right? So if we need to execute these transformations in here on data sets that contain billions of rows, then we can just scale up the compute profile to practically any kind of resources that may be necessary. So this is not just kind of a toy tool that allows people to build quick analysis. This can be used to build production-grade pipelines. But yeah, so much about Pipeline Builder. Let's jump into the specifics. So what do we want to do? We essentially want to bring all these different kinds of tables into these two formats, these two schemas needed for process mining. So let's start actually by doing this for one specific example, and then we'll kind of skip forward until this has been implemented for all relevant process steps in the order-to-cash process. Let's take the VBIP table, or the sales document item data table. This basically contains all of the sales order items that have been created in SAP. So contains a lot of different information. And one log event that we would want to derive from this table is just the creation of a sales order, right? If it's in this table, it's been created and there's a creation date in this table. So let's quickly build this. We select the transform interface here, and then we see all of the different kinds of things that you can do, right? A lot of different options here. In the beginning, we just want to select the relevant columns, right? Because there's so many columns in here, not all of them are relevant for this. So what we really only need here is the primary key of the order so that we can trace the step to a specific entry, and the creation date, which was this date on which the record was created, or ERDAT, the technical field. Once we have that, we then need to transform the creation date into a timestamp format, right? We want to track this on a minute and second level, not just on kind of a day level. So we can just use the cast function for that, and basically turn this field into a timestamp type, which is super useful. And let's actually call this timestamp because we will know what the step means by actually defining it in the next step by adding a constant column, which is our state. And obviously, because the timestamp describes the creation date, we want the state to be something like sales order item created. Perfect. So now we have all three columns. However, we also have to drop one column because this creation date is no longer necessary because we have the timestamp. Perfect. So now we actually have a very early version of what we wanted to build for the log object dataset, right? We have these three columns down here. You can see this in the preview. The state column, the timestamp column, and the primary key column of the sales order item. Amazing. So now that we've skipped forward, we can actually see that all of the different steps in the order-to-cash process of Titan Industries have been brought into log format through Pipeline Builder, right? When we go onto the right side here, we can see the additional step definitions that have been created on top of the sales order item created step that we built together before, right? We can, for example, see that there's a goods delivered step where we now have logs on this specific part of the process. And we also have this, for example, for the invoices being paid or basically anything else, credit blocks being removed. What we now want to do is to bring this into one giant log data set that combines all of these different data sets. So we can basically just do a group selection here and then click on union tables up here. And when I select that and click on create union, I see that all of these different individual log steps of goods delivered, right, sales order item created, all of the things that we've just talked about and seen built out are basically brought into one giant data set. And of course, we want to keep this nice and maintainable and readable. So let's actually give this step a name. So let's call it union process log steps. Perfect. And then we can go back to the graph. The only thing that's missing from here is storing this data set in the storage layer of the platform so that we can continue working with it in the next step. And we can do this by selecting Add Output and then clicking on New Dataset. So this does just that. From here, once we click on Edit, we can configure certain things, like giving the dataset a name. In this case, it's the log object dataset, right? Because it's the backing dataset of the process logs. We can also define things like the property types of certain properties or configuring data expectations, which is really useful because basically this will alert us in case the data in the underlying system changes in a way that we don't expect it to. And therefore, we can kind of guarantee that in case something like this happens, it's not directly propagated through the end application, which helps promote trust in the data that is displayed here. So very useful features for really production-grade applications with process mining. When we click on Back to Outputs here, we can see that this has also been done for the process object dataset in the same way. So this dataset is now also stored in the storage layer of the platform. We now fundamentally have everything that we need to go to the next step of building the ontology based on this process data. Keep in mind, however, that you also need to perform some additional process mining specific transformations, such as deriving the total process duration per process object, right, or per sales order item in this case. And this is really, really easy to do, as you just need to compute the time difference between the first and the last timestamp of a given order. In case you're interested in how to do this, there's also a lot of useful documentations here. And you can just access the platform documentation by selecting this dial in the bottom left here. And we can just type in set up process mining. And we can already see all of these different examples of what you need to do to bring this into the correct format. So now that we've already built a pretty big chunk of our workflow, let's do an intermediate recap. So far, we've synced relevant data sources to the platform using our HyperAuto integration tool. And we've brought this data into the format needed for process mining using Pipeline Builder. Before we can get to the process mining step, we now need to connect the order-to-cash data to the ontology. The ontology is the decision-centric model of Titan Industries, so the place in which all of its data, logic, and actions are stored. As this is the foundation piece for any data-driven workflow within the company, we want to make sure that everything is well connected and can speak to each other. Let's get back to building now. To create the order-to-cash ontology and link it to the existing decision-centric model of Titan Industries, we need to add objects for both previously created order-to-cash datasets. We can do this from the dataset preview, for example, or we can select Create New Object Type from the All Actions menu. We then transition to the ontology manager, in which we have to configure the new object type. In here, we can choose things like the name of the object and give it an icon as well as a color, so that also non-technical users can intuitively comprehend what these objects are describing. Now that this has been set up, we're actually in the menu for editing this object type. Here we can fine-tune the object and specify how it should interact with the rest of the platform. For example, by configuring access management in the security tab, or by calibrating property metadata in the property tab. Naturally, all parts of the ontology are deeply interconnected. For example, a sales order is of course always connected to a specific customer. That only makes sense because of course this customer is the entity that has initiated the creation of the sales order in the first place by ordering something from Titan Industries. So let's also create this link here in the ontology to this customer object. We can really easily do that by selecting create new link type here and then selecting the object type that we want to link the sales order item with. So let's select Titan Industries customer, and then we kind of have to select the cardinality here and can define the join key. So in this case, the customer. I've skipped forward now, but you can see that I've also set up a similar link to the process log object here, because of course, these objects are intricately linked as well. One sales order item can go through several different states in the process, so there's a one-to-n relationship between the sales order item and the process log object. We could, of course, continue linking these different types of entities to build an even more realistic model of Titan Industries. But we'll keep it simple for now and continue moving to the next step. Keep in mind, though, that the ontology will be connected to our generative AI capabilities at the end of the video to make our process mining workflow AI-centric. And naturally, the better the ontology is defined here, the more effectively our AI tools can get to work. Now that we've built our ontological representation of the order-to-cash process at Titan Industries, we can deploy Machinery. As a reminder, Machinery is Foundry's process mining application. We will use this application to create a process model that we can then visualize. And by doing that, we can discover unexpected process flows, bottlenecks, or loops within the process. With this knowledge, we can then directly take action to improve the process, which becomes especially powerful when we combine these capabilities with AI-centric logic. And that's exactly what we'll do, of course. Let's start by opening the Machinery app in the application panel. We can see here, right, Foundry Process Mining and Automation. This is the correct solution, so let's click on Open. In here, we can create a new process model by clicking on New Process in the top right corner. What we now see is the Machinery configuration wizard. Here we have to select which process objects from the ontology we want to do process mining on, and select those properties of this object that specify the state transitions in the process flow. Now that all of this is correctly configured, I can actually create a new process. I then have to pick a name and a suitable location. And once I click on Save, Machinery will analyze our process and log objects together to derive which process paths happen in the underlying systems at which points in time. For example, our sales order item objects might be credit blocked in some cases and might not be credit blocked in other cases. Machinery can differentiate between such cases as it can interpret the contents of the log object. When this analysis is finished, Machinery then creates a graphical visualization of the process flow, and that is what we can see here. In this graphical configuration interface, I can just drag process steps or nodes to the position that I want them to show up in later in the end-user facing application. Right? I can just select a node here and place it wherever I want. I'll skip forward now, though, to the point at which this looks exactly as we need it for our credit block management use case. Perfect. Now we can see the process flow in exactly the same way in which it was also displayed in the end-user facing application that we looked through in the beginning. This finally allows us to investigate the process variants that contain credit blocks, which we originally set out to do in the beginning. Keep in mind, though, that this manual node positioning step here is completely notional, as there's also a way to automatically place these nodes in your user-facing applications later. However, for our case of credit blocks, it is quite a powerful thing to be able to do, as we can pay particular attention to this process variant in this way. And this is already super useful, right? I mean, now we have a data-backed evidence for the existence of this process variant. We see that the sales order item created step can be directly followed by the credit block activated step. And from now on onward, we can use this process model to observe how frequently this process variant occurs, as new sales order items are created and potentially credit blocked. Being able to investigate this process variant in detail also lays the foundation for our AI-centric resolution workflow that we of course want to build later in the video. We finally have to configure some additional links of this process model to the ontology, like for example selecting the involved process object. We can do that on the left here. Now we're all set. Let's finally save the configured process model and move to the next step. Now that we have built our process model using Machinery, we of course want business users and analysts to be able to interact with it. To do that, we will embed the process model into a workshop application. You probably remember from the beginning that Workshop is our low-code, no-code environment for developing front-end applications on top of the ontology. Workshop provides a simple drag-and-drop way for building out frontends. And you can see this here. When I go into the kind of final deliverable that I showed in the beginning and click on Edit and Edit Module, I can basically see that this entire app is just a collection of widgets. And I can simply add new widgets by adding a new section and clicking on Add Widget. I could select here from various different options, like object tables that basically display a list of objects along with selected properties from the ontology in tabular format. Also, we can use charts that allow me to visualize data from the ontology. And in the same way, process models are simply just widgets that we can embed here. And when I click out of this and select the process model that we've embedded, we can just see that this is basically like any other widget that we've just embedded here and configured it to use the process model from Machinery, the graph basically, and process objects that we can also filter down in Workshop to have dynamic interactions with the front end as well. You can see that here, the process object and the log object set. Using the front-end development options in Workshop, we can build an end-to-end process mining application that also includes filtering options, options to calculate KPIs, or entire operational views in which all relevant information is displayed in order to make a decision. With all of these things we've built until now, we can almost entirely build the app from the beginning, right? Using this Workshop app, business users can already make decisions effectively because all relevant information is provided here, such as the customer credit information, the sales order metadata, or the process flow until now. The only thing that's still missing at this point is the AI Copilot. And this is exactly what we'll get to now. Coming back to our agenda, we're now almost all the way there. We've mined the order-to-cash process using Machinery and then built a basic Workshop application that allows business users to manage credit blocks on top of the mined process model and the ontology. In the final part of this video, we want to make this so far manual application AI-centric and also automate AI-orchestrated decision-making. To do that, let's jump into AIP Logic, which is a no-code, low-code development environment for building LLM-backed functions. These functions can power both applications and process mining capabilities through the ontology. And this tool allows builders and architects to embed generative AI in the form of large language models into basically any workflow. You might have also seen it in use for other videos that are part of the Building with AIP series. What we want to do here now is teach the generative AI model or the LLM to make a decision about whether to maintain a credit block or to deactivate it, right? And you can think about this like teaching an intern. So someone who is intelligent, but so far doesn't have a lot of context in how to perform the task at hand. In the beginning, we have to first define an input object from the ontology that the LLM can then work with. And we do this up here, right? We define the sales order item as the input. We then also store specific properties from this object as parameters so that we can reference them when teaching the LLM how to perform its task. And that's what we can see here, right? These different parameters that we also saw in the Workshop app, based on which the human decision maker can make this decision, like the credit status, the customer credit limit, the historic order volume, right? All of these different things are provided here so that we can reference them. And then in the next step, we actually get to the part where we then really instruct the LLM how to perform this task. And this is super intuitive because we can just write in plain text what the LLM should do. We don't need to code here to interact with the generative AI. We only need to be able to speak a language. And we start by kind of high level providing instructions here on what needs to be done. So essentially, this is just saying your job is to decide whether to unblock the given order or to retain the credit block on its on the given order, given the provided information. Then we can define the properties and explain them to the LLM. And this is what we actually do here, right? In the same way that I've kind of explained to you what a credit status is, the LLM also needs this kind of context. So we have to provide it here and kind of explain what all of these different parameters mean. After we've done that, we then provide a set of rules to check for. So for example, to check here, if the given order might be a good risk to take, given the provided properties, or if it may be a bad risk to take, maybe because all of these parameters look so bad that basically the block has to be retained. Since the LLM also needs to compare numbers as part of these rules, and needs to kind of check for these, it's really important that we also provide the adequate set of tools here. And we can actually do this up here, where we've added the calculator tool. You might already know that LLMs really struggle with basic math. So it's quite essential to add these kinds of tools that allow them to kind of make calculations reliably so that the output quality is always consistent. So super important here. So when it then kind of compares values as part of this step here, this tool is just really important for the output to be good. Great. So once it's kind of established how the LLM should make the decision, we ask it to also provide a reasoning for why it's come to a certain conclusion. And then we also store that in a certain variable down here so that we can refer to it in a later defined LLM block. The only thing that we need to do from here is store the decision and the reasoning behind it in the ontology, because we of course want to embed this decision into the end-user facing application. And to do that, we allow the LLM to use another tool, which is calling an ontology action down here. So here we say carry out the instructions below. We've defined the apply actions tool, and then say given this reasoning where we refer to the previous block, would you unblock it or not, and kind of store that in the ontology using the provided tool. Then down here, we finally say the output should be this block here, which is the output block, and it should do these ontology edits, right? It should store this in the ontology as we've just defined up here. Let's now test how this works by using the debugger tool. And you can see this on the right here. I can basically run this logic function that we've just defined for any given object that is in the ontology. So for the one that I've just put in here, I know that there's currently a credit block active. So let's select this one and run the debugger, and then we can kind of watch the LLM think, right? We can, together with the LLM, go through all of the different steps that we've defined together, all of these different kind of conditions that need to be checked, and see what the LLM comes up with. And also, and this is really useful, kind of gives us back how it's understanding the different instructions and what it's kind of doing based on this. So super useful to kind of see how the LLM comes up with a decision. And this is really useful, especially for kind of the development part. So we can kind of see if the LLM is understanding the instructions correctly. Great, let's kind of skip down to the bottom here. So now we can kind of see what has been stored in the ontology. And we see that in this specific case, the reasoning is saying that the order should be unblocked because it's a good risk to take, right? The open order value from the customer as a whole is at 3.6 million euros, which is only slightly above 3 million euros, which is the credit limit. And because the customer is paid on time pretty frequently, and 97% of cases, this is pretty likely that the customer will actually pay for this specific order. So everything works as expected, and we can now plug this into the end user facing application. Now skipping forward, we're actually back in the Workshop app, and you'll see that the AI's decision and the reasoning behind it is now displayed in the bottom part of the screen, right? We can basically add this as a text box and as a process flow visual that's highlighted, right? Going from credit block activated into the credit block removed stage. So what we've done here in the last couple of minutes is really quite remarkable. Let's put it into perspective. You might remember a couple of minutes ago, I said that this app, or at least the earlier version where only kind of this part here was available, allows business users to make decisions more effectively because all of the relevant information is provided. But now they don't even have to do that anymore, as we've shown that the AI can make these decisions for them. Of course, this is still a human-in-the-loop setup where the human ultimately decides what should be done in this context, right? In the end, I still have to click deactivate credit block or reject the activation proposal. And this is probably also good in the beginning to validate if the LLM makes the right decisions and to build trust. However, this could also be run fully autonomously using our tool Automate. And this can be set up in just a minute using the data logic and decisions we've already configured in the ontology over the last couple of minutes. We will actually release a detailed video on Automate soon, so I'll keep it short here. What you can actually see right now is that I've already set up an automation in the window. We just need to save. Let's quickly talk it through so you get the main gist. So what we can do with Automate is basically define triggers that are continuously checked by the platform. So I can see this in the condition tab here, right? I'm basically checking every couple of minutes if objects have been modified and if their last step is currently credit block activated. So I'm kind of checking if there is a new sales order that is now in this state. And when that is happening, I execute the credit block logic, right? I execute this logic that I've just defined together with you in AIP Logic to kind of check what decision needs to be made, if the credit block should be retained or if it should be removed. Now I can basically save this down here, and then this is immediately active. When I now jump back into our workshop application and investigate the Machinery widget, I can actually see that the process node in which the automation has been defined is now highlighted in purple, indicating that the automation is active, right? So continuously, this is tracked. If there's a new order in this part of the process, then the logic is again executed and of course could kind of directly take action much more quickly than these 9 days that would usually be taken if someone had to manually check this. So now let's jump back into the agenda for today. As you can see, we're now completely done and have built this powerful workflow from the ground up. We also achieved our goals from the business perspective, as we on one hand know exactly how the credit block problem is affecting Titan Industries' process, and on the other hand have built an AI-centric solution that can help the company deal with this problem much more effectively going forward. Taking a step back now, I want to stress that this is of course just the beginning. Dealing with credit blocks is of course just one problem in the order-to-cash process. There are dozens of other inefficient sub-processes that could be performed in a more optimal way using such an AI-centric solution. And of course, this also applies more broadly beyond just order-to-cash. Basically, anytime a human needs to make a decision in a process, the approach we have just gone through applies. Instead of determining whether to remove or retain credit blocks, AI could also help with making decisions in other core processes within the enterprise, such as answering which conflicting production schedules should be prioritized, which leads in the sales funnel should be reached out to first, or which purchasing contract should be used when ordering a particular good or service. Imagine a world in which you build a completely AI-centric process architecture, in which hundreds, if not thousands, of similarly tasked AI copilots take care of all these problems that are slowing your operations down. That is, of course, the level to which we want to take this solution paradigm with you. I hope that you could take that away from this video, and that you now understand why process mining, AI-centric logic, and automation are such a powerful combination. Thanks for your time, and speak soon.